Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. Today we are covering CCNA Semester 2, Routing and Switching Essentials. This is Chapter 2, Basic Switching Concepts and Configuration. Chapter 2 is divided in two sections. We have a section 2.1, Basic Switch Configuration, and then we move on to section 2.2, Switch Security, Management Implementation. On section 2.1, Basic Switch Configuration Objectives, here we configure initial settings on a switch. We configure switch ports to meet the network requirements, as well as configure the Management Switched Virtual Interface, which is SVI. Basic switch configuration, switch boot sequence. First we have ROM, read-only memory. Now read-only memory is non-volatile memory, which means that it doesn't need electricity to retain the data. In there we have something called post. Now post is power on self-test. So the switch will do power on self-test. As soon as you boot up, it will go through the test, making sure all the components are working or functioning as they're supposed to. Power on self-test, pretty much every device will do. Even your TV will do power on self-test, or washing machine or anything. All the devices, they have this. And then we have a bootstrap. Here, the bootstrap, it will tell the switch what to do next. What's the next job for the switch? For example, it will say, okay, well, you do need to go to the flash and locate and load the operating system. So the switch will have to go to the flash, find out the operating system, take that operating system from flash or iOS from flash and load it into RAM. So you can think of, for example, let me just put a pointer here. For example, down here you have RAM. So this will be your RAM. On RAM, okay, take the iOS from flash and we load it into RAM. Now it's called a running operating system. If it's not on the flash, it's going to be on the TFTP server. So if you can't find iOS in the flash, have a look at the TFTP server. Maybe you find it there. After you load the operating system, then we go to the NVRAM. So go to NVRAM and locate and load configuration file. We call it a startup config. So the switch will go to the NVRAM, locate the startup configuration file and load it into RAM. Now when we load it into RAM, it's called a running configuration file. So here is a startup configuration file. When we load it to RAM, it's running configuration file. The startup configuration file could be located on TFTP server as well. So either NVRAM or TFTP server. If it's not on NVRAM or TFTP server, then it's going to be the console. But in console, we will get that wizard, you know, the initial startup configuration wizard. So enter setup mode. So ROM, power on self-test, load the bootstrap, locate the iOS. iOS could be in the flash, or it could be in TFTP server. Now, if it's not on the flash or TFTP server, then it's going to load up the limited version of iOS. But the flash, for example, if we load it from flash, it's going to go to RAM and it's called a running operating system. In flash, we do store other files as well. This is just like a storage, yeah? We can store VLAN database, we can store other files as well. Flash is another type of non-volatile RAM. Non-volatile, yeah, which means that you don't need electricity to retain the data. NVRAM is non-volatile RAM. That's what it says from the word. So here we can put the startup configuration and it will retain the data without power. RAM is volatile, so it does need electricity to retain the data. So in RAM, we have a running configuration and running iOS. In NVRAM, we have a startup configuration file. In Flash, we have iOS as well as VLAN database, for example. And in ROM, here we have a bootstrap program or we have a partial iOS. Now, when we load an operating system, the switch is what it's going to do. By default, it's going to go and find out the first operating system and load that. If we have many operating systems in Flash, for example, 2 or 3, we can say, okay, well, don't just go and load any operating system, the first operating system you find. We can load only this operating system. For example, with the command in the global configuration mode, we type boot system and then the flash and the location of the operating system. In blue, this area in blue here is a folder. right? So that's a folder, and that's actually the operating system that we want to load it up. If boot system command didn't start up, the run boot system command in order they appear in startup config to locate the operating system. If boot system commands fail, so if you mistyped something in here, then use a default fallback sequence to locate the iOS. So first, if for example you mistyped it here, you didn't put the Z or whatever, then okay, well the iOS says fine, this is wrong. So what I'm going to do, I'm going to revert to my default sequence. So I'll first load up the operating system. The first I find, I will load that up. If there's no operating system, I will go to TFTP ROM and try and find the iOS there. If not, I'll revert to ROM, which is limited iOS. So each port switch LED indicators or LED indicators. Each port on the Cisco Catalyst switch have a status LED indicator lights. LED lights reflect port activity, but they can also provide other information about the switch through the mode button. The following modes are available on Cisco Catalyst 2960 switches. For example, we have on the top here the system LED. As soon as you turn the switch on, you will see this, it will start blinking in yellow. Then the next port is if the switch does support redundant power supplies. So if at the back you can connect two power supplies, you will have this port on as well. The port status LED, if the port is on, then we will have a duplex mode. If the duplex is on, then this light will work. Then we have a port speed LED, and as well as power over Ethernet status if is supported. And then lastly, we have a port LEDs. So as you are actually connected cable here, the port will start flashing orange first, maybe, and then into green. I'm saying maybe default it would, but you can transition from down into forwarding right away with some commands. Then we have a mode button. This button that we would use if we want to recover the password. If we forgot the password we want to recover, we use this button. So how do we recover from lost passwords? For example, you go to this switch and you forgot your password, or you bought a switch from eBay or whatever, you don't have the password. What you have to do, you have to unplug this switch. So there's power cable at the back. So if I can draw it like this, that's maybe not. Okay, down here is your power plug. So you unplug that, right? You take it off, and then you press this button, which is mode. You press it here, and you plug back the power. You put the power back on. While you're still pressing this mode button, now you'll wait about 10 to 15 seconds. The system LED light will actually go briefly into amber and then to solid green. Then you can release the mode button. I did find out that sometimes this doesn't really work as it says. So what I recommend you to do, after you plug in the cable, just count like 20 seconds and then you let go. Then you should have this prompt, switch prompt here. Now once you get this prompt, you have to type in flash init. So type flash init. Do I have here? Can I type? No. Okay. Because if I type with this pen, is not very good. I tried it. Flash. Yeah. See, it's not great. Flash underscore init. What I do, I will open let me open Notepad. I'll open a Notepad. Here, I got one open. Okay, so here, what I'll do, after you have a like this, switch prompt, right? Then you type flash underscore init, and you want to see the directory of flash, yeah? So you do directory flash. What you want to see in there, you want to see a file called config.txt, right? So not txt, it's text. And what you want to do, the password is stored here. So here is the password. So what you want to do, you want to actually rename that. Rename this, right? So to do it, you have to go rename, flash config.txt and to flash config.old, right? After you press enter, you do dir flash again, dir flash, just to see that did take effect. If it did take effect, like you want to rename, it actually worked, you say you don't want to have this in there, and then you say reset. Reset is going to reload the switch, and there's no the switch is going to go through, it's going to load the operating system, find out that there is no operating system there, so it's going to find out, okay, fine, I'm going to load up your normal configuration. Without any configuration, you're going to go through the wizard, the initial setup. After you log in, so you will be in the on the privilege mode, like this, in the privilege mode. Okay, you will be on the privilege mode, like this, and then in there you can show flash to see what's in the flash. Now on the flash you should see config.old, and here you can say rename flash config.old to flash config.text. And then you can, what you can do is after you rename that, then you can go and change the password and so on. Okay, so that's the way to do it. You unplug that cable, press the mode button, plug the cable back in. While you're pressing the mode button, keep the mode pressed for about 20 seconds and then let it go. When you see this prompt, you are in the good path. And then you type flash in it. You have to do that to initialize the flash. The dir flash, so you want to see directory, and you see a file like this. What you want to do, you want to change this file. You want to rename it. So the command is rename flash config.text to flash config.old. So see that it did take effect. If it did, reset it, and then show flash, it should say config.old. Then you can go and rename the config.old flash config.old to config.text. And then you can say copy, if you want to copy flash config.text to system running config. This will copy the whatever that file used to be into running config, but you are in the privilege mode now, so you can actually make changes, change the password, and so on. This will be a lot easier to explain to you if in a live demonstration, but here is the best way I can do it. Now the switch, you need to prepare the switch for basic management. Now if you want to remotely connect the switch to the switch, the switch needs to have an IP address. You can't connect to the switch without an IP address. So if we have, for example, let me just stop this and start a packet tracer here. Yeah? For example, when I get a switch, there's no way that I can actually start configuring that switch, because that switch does not have any any displays I can press or something. So the only way to do it is actually have a PC or laptop and connect to that switch through the console cable. So connect console at the back of the PC, and then go to the console cable, console port on the switch. Now at the PC, you install a terminal emulator like TerraTerm, PuTTY, and you start that. And then you have a connection to the switch. But for you to be able to telnet to the switch, remotely manage the switch like this, now this switch needs an IP address. Say this PC, we have an IP address, we give it to this PC, say 10.1.1.1, say 100, 255.255.255.0. Right, so the PC has an IP address, but the switch doesn't. So remotely, this is only way to configure initial configuration. You have to do it with the console cable. To give it remotely, you have to go to the switch, enable config t, hostname, say S1. And here the switch has one interface, like a virtual interface. It's called the management interface. By default is interface VLAN 1. So you go interface VLAN 1, give an IP address. So IP address 10.1.1. say 1. No shutdown. When we do show IP interface brief, we should see that interface is up. So layer 1 is up and layer 2 is up as well. Now I should be able to ping the switch. So if I go to the PC and open the PC and say ping 10.1.1.1. That was the IP address of the PC of the switch. Okay, come on. Yeah, we got a reply. Excellent. One more thing to do, if I go to package tracer, I just want to change the preference so you can see the text a bit better. So I'll go to fonts 16 maybe, and 16 this. Okay, now one more thing that I need to do to the switch is actually configure the VTY lines, yeah? So after we there, so config T line VTY 0 to 4, password Cisco, and login. We are telling to use that password for logins. And one more thing that we have to do for remote log config, secret. We need to enable the secret password. Okay, so now we are ready. So if we go to the PC, and well, we were in the PC, but from the command prompt now, right? We say telnet 10.1.1.1. We have a password Cisco enable class. And now we can remotely manage this switch. That's the only way. Once we've done that configuration, that initial configuration, we can get rid of that cable and we can remotely manage the switch. Okay, now if we have a router here and this switch is connected to a router, doesn't matter the port, and I have a PC as well connected to this side, right? So crossover cable, since the router and PC, same device. Okay, these two devices are going to be red because they off by default, yeah? So if you go to the router, no, enable, show IP interface brief, see, they're down, administratively down. Right, so if I say config T, interface FA00, give an IP, just going to do no shutdown. I'm not going to have a test, I'm not going to test this, I'm just going to explain something, right? So no shut. Just so it's nice and green there. Right. Fast forward time. Now, if this PC, for example, telnets to the switch, right? The switch, it doesn't know how to send data back to the PC. So for that reason, the switch needs to have an IP address of the router, right? So let me zoom in a little bit, right? So for that reason, this switch has to have a default gateway. So imagine this router IP address is 10.1.1.254/24, right? And this side, we're going to give an IP address of 10. Let's say 172.16.1.1/24, and the PC will have 172. If I click it, yeah, 172.16.1.2/24. Okay, so if I go to this PC, give that IP address 172.16.1.2 255.255.0, and the gateway 172.16.1.1. Okay, now I said that I'm not gonna do it, but I'm gonna test this anyway. So if I go to this router and say interface FA00, that was the interface this site, IP address 10.1.1.254. So let's move this here and this on the right here, yeah, like this. 255.255.255.0. I did not shut down, but just out of habit. Interface FA01 is the other IP address. 172, the other interface. .0, no shut. Yeah. Okay. So now, this PC will not be able to, the packets are going to go to the switch, but they don't know how to come back. So the switch needs to have this address as a default gateway, otherwise it will not work. The packets to make that possible, you have to go to the switch and create a default gateway. So enable, what was it, Cisco, was it? Class, config T, IP default gateway. That should be 10.1.1.254. Here you don't need to put a subnet mask, it's just a default gateway. It's like the PC, we give an IP address to the PC and subnet mask, but for the gateway we just give an IP address of the gateway. Okay, so can can we ping our gateway here? Ping, say 172.16.1.1. Yeah, we can ping the gateway. So now, can we ping the switch? Ping 10.1.1.1. Let's see. We're gonna lose op. Yeah, we can reply it. So we have a reply from the switch. Now we can telnet to the switch. So telnet 10.1.1.1 Cisco enable class. Now we are in the switch, show run, for example, and do the configuration here. So the network here, this is the network. Let's put the some colors here. Here, this network, you don't need any devices. The switch doesn't need the gateway because it's a local network. So if it's in the local network, you don't need the gateway. But if you're thinking of managing the switch from a remote network like this PC, the switch then needs a gateway as well, default gateway. Cool. Now the interface that we configure on the switch is called the switched virtual interface, SVI. By default is VLAN 1. Now you can create any VLAN that you want. You can configure the VLAN 99 as well, like we have it here on the screen. Now make sure that we do no shutdown, because that's going to enable the interface. By default is down. But it's not going to work if you don't have VLAN 99 to start with, and if you don't have any ports assigned to that VLAN, which we can test it, yeah? So let's go to that switch, and let's do show IP interface brief, for example. If I can zoom in, right? Now we can see VLAN 1 is there, right? So now what I want to do is I want to go to that VLAN. So interface VLAN 1, shut it down. Shut down. I don't want VLAN 1. Show IP interface brief. You can see VLAN 1 is administratively down. The only interface is actually administratively down. All of these are just down. There's nothing connected to it. There's something connected on port 15, and then port 1, I think. Yes, something connected in port 1. Now I can create a new VLAN. So they say leave the VLAN 1 empty. Don't put anything here. So okay, let's create an interface VLAN 99 as we had it on the slides. But now do show IP interface brief. You can see the VLAN 99 is down. Down layer 1 and down layer 2. Now the reason why it's down is because we don't have any VLAN. So do show VLAN brief. Okay, that's it. We don't have VLAN 99. So that's why it's the first or the layer 1 is telling us that it's down. So as soon as we create a VLAN, this is going to go, layer 1 is going to go up. So exit here, VLAN 99. So as soon as we send VLAN 99, look, the port has changed state to up, right? So if I do show IP interface brief, it's up, layer 1, but layer 2 is down. So to make this layer 2 up as well, we do need to take one port and stick it on that VLAN. Because if I say do show VLAN brief, you can see the VLAN 1, it's active, but there's no port on it. So if I go to and take that port 15 and stick on VLAN 99, that will enable the VLAN to go up. So layer 2 as well. Okay, so to do that, interface FA015, switch port mode access, switch port access VLAN 99. Now you see, has enabled the interface to go layer 2 up as well, yeah? So do show IP interface brief. Look, now it's up. Layer 1 and layer 2 is up. It's working. Now this switch is layer 2 switch, so it's not, you can't have two IP addresses. So we never assign an IP address. Interface VLAN 99, VLAN 99, IP address, say, okay, let's just change it now. Yeah, so say 192.168.1.1, 255.255.255.0. No shutdown. No shut. Now, this switch is allowed to have only one interface for management, right? So here we have configured this. we made sure to configure like this VLAN 99 that we have that VLAN, otherwise layer 1 and layer 2 will be down, and make sure that there's a port, active port on that VLAN, otherwise the VLAN layer 2 will be down, or that interface. Default gateway, like I said, you need to put IP default gateway and point it to the default, the closest port of the router. Okay, there's a lab here for the guys. If you were studying in the academy, that would be the lab for you. Duplex commands, or duplex communication, you know the communication within the switches can be duplex, half-duplex. So duplex you can send and receive simultaneously. In half-duplex communication you can send or receive, but you can't do both. You can reset like this yourself. You can say, okay, well, go to the like physically, you go to the configure a switch port on the physical layer. You can go to the interface and set the duplex to full, and then choose the speed as well. Now, the Cisco does recommend that you leave this to the auto, right? With the auto, what they're going to do, they're going to negotiate with each other and find out what is the speed of the neighbor. Now, if you remember the cabling, if we connect two switches together, we're going to need the crossover cables. If we need to connect switch and hub, we need a crossover. Router in the switch, straight through. Router in the PC, crossover. So cable is very important. Now there's a new feature on the switches that it doesn't really matter what kind of cable you have, as long as you connect it. It doesn't matter if it's crossover or straight through, it will work. And this is called the Auto-mdix feature. Now Auto-mdix is not gonna have a problem with the type of cable you have connected, because it's gonna fix the ports. It's gonna sort out the ports the way it should be. Now this is okay, it's here, but you know, all the exams and everything, make sure you remember where to put the straight through and where to put the crossover cable. Now Auto-mdix feature, it does work, but it has some important kind of like settings that you have to make sure that they are there. The duplex has to be in auto, and the speed has to be in auto for it to work. So let me just write this duplex. For these to work, all these three, they have to be set to auto. So if you set duplex to full or half, for example, this is not going to work. If you set the speed to 10, 100 or 1000, it's not going to work. So they have to be in auto. To check, show controllers, Ethernet controller, fast FA04/1, PHY, then pipe. And what do we want? We want to include only Auto-mdix. Is it on or not? Only MDIX. And yeah, it says it's on. Now to verify the switch, we have some commands. Show interfaces. Now show interfaces, what is going to tell you mainly like a layer 2 information. And so if you want a layer 3 information, you stick an IP in front, show IP interface. Show startup config is show running config. You should know, you should be very familiar with them by now, semester 2. So this is going to display the running configuration on the switch, and this is going to display what you have saved. These two doesn't have to be the same. So you could be like a notepad, you're working on it, but if you don't save it, you're going to lose everything. Show flash, whatever is stored in flash, for example, the operating system, the VLAN database. Show version, if you want to, for example, sell a switch or router or anything, you do this show version and you stick an eBay. That will tell you pretty much everything. How many ports he has, what kind of interfaces, what version of iOS is running, how much RAM, how much NVRAM. Pretty much is going to tell you everything that switch or router is capable of. Show history. This command will display what you have typed. By default, we have 10 commands stored in the history. Show IP interface, like we did, show IP interface brief. And then we have a show MAC address table, or show MAC without hyphen address table. That will give you display the same command, and that will show you what's in the MAC address table on the switches. You remember how the switch learned the MAC addresses. It looks at the source and it builds this MAC address table. By default it's empty, there's nothing in there, and then as the frame come in, the switch looks at, okay, port 1, new frame, MAC address AA, let me write that on my MAC address table. Now that is on MAC address table. It will be there for 5 minutes. So when we do, for example, show interface FA01, here we see layer 2 information. What do we see here? Quite good information, quite a lot. We know here on the top, let me just write it down if I can. Yeah, in the top, right here at the top, we see layer 1 is up. So that's telling me that layer 1 is up, and it's telling me layer 2 is up as well. So, and it's connected. Okay, good, it's working. Now it's got layer 1 up, layer 2 is up, show interface. Here is, we can see the MAC address table. What MAC address table do we have of the switch, of this port? We can see the bandwidth of this port, how much bandwidth it has in kilobits per second. So which is 100,000 kilobits per second, or 100 MB. We can see the full duplex that we run it. What duplex we're running full. We have 100 megabits per second, the speed. The next thing we can see here are in the future learning and so on, you'll see like a quality of service information here, which is we use in first in, first out on the packet, on the frames. But other information, important information here is this giant and runs, right? This yellow has moved. I don't know why it has moved. So for example, here we can see 0 runs. This will tell you how many frames they've been smaller than 64 bytes minimum. So minimum, if the frame comes in less than 64 bytes, they are called runs, run frame. Now, giants, or baby giants, these are the frames that they go longer than maximum allowed. So, sorry, larger than maximum allowed. The next thing here we can see if we have any CRCs errors. So 0 CRC, there hasn't been any error here. The next thing we can see is important stuff here is collision. How many collisions is there any collisions? So 0 collisions here. And we can see, for example, late collisions, if there's been any late collisions. Late collision, this will start increasing if you have duplex and or half duplex mismatch or something. Okay, thank you very much for watching my video. And the next video we get into is switch security, management and implementation. Thank you very much. This has been Astrid Krasniqi. Please don't forget to subscribe and watch other videos. Good night.